So I'm here to show you how you can use some core Unix concepts to speed up your Rails test runs. And this isn't a completely new idea. This is basically the same approach that's used by the Spork gem or the Spin gem that I wrote, or the Zeus gem, or there's a couple others that are kind of doing what Zeus is doing, more or less. But I'll show you the core of what they're doing. So I have here the rubygems.org Rails project. I picked this up because it's an open source project, but it's also a pretty big Rails app. And it suffers from a lot of this one issue that a lot of big Rails apps have, which is when you want to run a test, I'm running the user test, I'm talking. Oh, I'm having an issue connecting to Redis. I've got a funky Redis here with my box and let's try that again. When I want to run a test, I'm keep talking because it takes a considerable amount of time. Wait for it again. It takes, let's see, almost 5 seconds. And as you well know, the smaller that time is, the happier developers are. So sometimes take over 5 seconds. When you're making a lot of changes, in the user model or in the application code, and you want to make sure that nothing's breaking, you want those feedback loops to be super short. So I'm going to show you how you can reduce some of that time. And if you think about why that's so slow, when you do this kind of thing, Ruby, and pass it a test file, it has to go through and not only load the test, it has to load the entire environment. It has to load the Rails framework, all of your gems, all of your application code, and then actually run the test. And you can think about, typically the Rails framework and the gems aren't going to be changing between test runs, at least not very often. So that's what we're going to try to optimize away is the time spent loading that stuff. And then your application code usually does need to be reloaded between test runs because that's what you're modifying. So the way we're going to accomplish this is we're going to set up like a test server script here. Oops, too soon. User bin and Ruby. And what this is going to do is, I'll spell out the steps. It's going to load Rails gems. Then it's going to enter a loop. It's going to just work forever. Take input, which is going to be a test file to run. Then it's going to create a new process and actually run the test. And I'll dig into that in a minute. So just first of all, a bit of Rails background here. We're going to require the config application file. And if you're familiar with this file, you can see config application is one of the, I think it's probably one of the first files that gets. Yeah, config environment loads config application and then actually initializes the Rails app. This is what we don't want because this is going to load all of the models and all of the controllers. You'll see why that's a problem in a minute. All we really want is this: load Rails, action controller, and load here all the gems. That's exactly what config application does. So we're going to require that. Enter a loop. We're going to take input. I'm just going to mock it to get started here. This is what we're doing on the command line. Trying to run this test. And then to actually run the test, we're going to ask this server to fork itself and then actually run the test file. So this is where the real interesting stuff happens. So what fork does is it creates a copy of the current process and then runs this block in that new process and then exits the process. So why didn't I just do this, right? Why didn't I just, in this test server, if I were to just have, taken the input and required it here, the problem is that this is going to, it's going to load all that environment into this process, all the models and all the controllers. And if I want this test server to be able to service multiple test runs and try and get rid of some of that load time, I don't want it to require all the models and controllers, because then I can't unload those changes. If you run the user test and then change the user model and run it again, I'm not going to see your changes to the user model. So fork here actually kind of keeps this parent process in like a pristine state where it's loaded Rails and the gems, and then it forks before it runs the test. So anything, any controllers and models that are being loaded here in the child process, which is not going to affect the parent. So the child process has like a hierarchical relationship where it inherits whatever the parent has in memory. So the parent has already loaded Rails and the gems, so the child is going to be running the test, can skip that step, and then when it loads the environment, the parent is unaffected. This is exactly what we want. The last thing I'm adding here is just getting the this gets the process ID of the newly created process here, and I'm telling the parent to just wait until the child's done. This stops it from going back to the top of the loop and forking another test run, because I don't want to have test runs going in parallel here, because with a single database they're going to start because we just have a single test database. Two tests could start modifying the same record at the same time, and we'll just have kind of random test failures. So we've got this test server, which is going to be loading gems and Rails, then taking input, which we've got mocked out. Then it's going to fork a child process, which actually does runs the test. And then when the child process is done, it is cleaned up. It doesn't exist anymore, and the parent waits for that to happen and then goes back to the top of the loop, takes more input. So I think we just need to finish this step, and then we can test the whole thing. And the way that I'm going to pass input around is I'm going to use a Unix domain socket. Now, if you've ever used TCP sockets, Unix sockets have a similar API, but instead of talking over hosts and ports, Unix domain sockets are to the local machine only. So they can only communicate on the same machine. And instead of using hosts and ports, they use a file on the file system for communication. So this is a file name I'm passing here, and I want to make it predictable so that when the little client that we write starts up, it can just hit the same file name, and then they'll be connected up. So this is going to be the server socket, and the way that we take input is, this is going to be connection. The server is going to accept a new connection on this socket. And this accept call is a blocking call. The server is going to block waiting here until a client connects to it. And once a client connects to it, I guess you can call this a client or call it a connection. And once the client connects, then we can get input from it. So the test file here is just going to be client.read. So we'll read whatever the client writes to us until EOF, until the client closes its write stream. And now we can get rid of this. And we should have what we need to get started. We'll make up a really, let's see if that worked. Make that executable. That's annoying. Let's move this to tserver so we don't always have collision. Cannot load config application. That's because it's not in the load path, so I can just kind of get it from the local directory. And I'll just, to try and reduce some of that input, I'll just trap the, whenever I get the interrupt signal, and just exit quietly. And the other reason I came here was, right, so this, just get benchmark in here too. This will just tell us it's going to tell us how long it took to boot up Rails. And a typo, of course. Benchmark. Cool, so we got the server, and Rails took about 2.5 seconds to load. So we can expect to shave that much off of our test runtime. Now we got to hook up a client too. So I'll go to rubygems.org, and I'll make up a little T client. Bin and Ruby. So it's going to need to collect input, create a socket, send data up to the server, and that's probably all it needs to start. The input is going to come from argv, so that's going to be as a command line argument, and then going to create a Unix socket at the same file name that the server is using. That's how they know to communicate with each other. Great. And then socket.write the test file, and I said I have to close the writing end in order to send EOF up to the server, so that it knows that it's got the full bit of data you need. Now I can try this out, make that executable. And we'll send test unit user test. Something failed right away. I could not load such file. I don't think this, I think again this is about the test directory not being in the load path. So cheat like that. Restart the server. Okay, so now I have a new error on the server. Testing.sock is in use, and that's because this file that the sockets are using to communicate doesn't get cleaned up when this process dies. Like when this socket closes, it doesn't clean up this file, and then when it starts up, if the file exists, it complains. So we need to set up an add-exit handler to clean up that file. I'll unlink it. And actually, a good trick that I learned from James Edward Gray is this is a little bit problematic, because this add-exit handler here is going to be also shared with this child process. The child shares, almost everything with the parent, or rather gets a copy of almost everything the parent has, including these signal handlers. This one is fine. This just means that when the interrupt signal arrives, the parent will exit quietly and the child will do the same. But now if they both try to unlink this file when they're exiting, obviously only one of them is going to be able to do it, and the other one is going to complain that it couldn't. So the trick that I learned was, since this is a closure, and we can get the process ID of this process, up here, and pass it into the closure here, and then say when this is actually running at exit time, we can compare the two. And only if the current process is the same as this process up here does it try to unlink the file, which means this child process will skip over this code and will not attempt to do it. Probably not wouldn't be the worst thing if both processes tried to unlink the file, but certainly more nefarious examples could exist. So for now, I'll have to manually get rid of that file, but it'll be managed from now on. Oh, and I used the wrong name. It's not process ID, it's process PID. Okay, so the testing server is starting up. What happened there? Oh, it was of course a typo in the add exit handler, so it didn't work properly. Lesson learned. Okay, so this one's booted up, and now the client, I can pass up the file to be run. And now another problem with the test environment, and that's because we're requiring config application here, but we haven't set the Rails env to test, and that would normally happen as part of the test helper, as part of the test helper loading, but we're kind of bypassing that here to preload some stuff, so we do need to fake that so that when the gems are loaded, it loads gems from the test group as well. So another thing to trip on, but I think we'll be a lot further along this time. Cool, now we can get the client to pass the test name to the server, and you can see it runs pretty quickly up here. And then there's one more gripe that I have, which is that now we need two terminals open, one to initialize a test run and one to spy on the output. Really nice if we had it down here, and we can certainly do that. How we so what the let's start with the server. So in the main loop here of the server, it's got a handle on the client, and here in the forked process, what it can do is reopen standard out to point to the client. So typically when you're doing something like puts, what's really happening is under the hood is standard out.puts is getting printed to standard out, which in normal test runs or something like that would be hooked up to the terminal, so you see output on the terminal. But you can repoint standard out to a file. It's pretty common if you're doing something like this on the shell. You can repoint standard out to a file, and you can do the same thing from your Ruby code. Repoint standard out to, in this case, a socket connection. So now when any of the test code tries to print something, it'll instead go put to the client. So we'll do that, and now the client needs to read the data back, and see it's just going to and what this would do would do a blocking read until it receives EOF, which send only when it closes the connections. We've got to make sure that the client connection gets closed when things are all done. But if we want this to look more real-time-ish, what we could do is won't even go there. We'll just do it this way, the easy way. So now this is going to be a blocking read until the connection gets closed, which only happens once the test run is done and the child process has been cleaned up, and then it'll exit after that. So let's see how the pieces all work together. So the server takes a couple of seconds. We pass up the test to be run, and this time we see the output right here in the client, which is really nice. And you can see now we're down at 2.8 seconds or so, 2.4 seconds. So we've essentially cut the time to run a test in half, and we haven't sacrificed flexibility. So if I go to the user model and comment out something which should break the tests, the tests do break, which is great. and if I fix it, then the test pass. Because we haven't preloaded any of the application code, right? Just the Rails framework and the gems. So if you were to add a new gem and try to build new behavior on it, you would have to restart your test server, but it's not such a big deal. So 2.5 seconds is still more than more than 1 second or half a second. We've essentially cut the time in half for free. There was no code changes made to RubyGems code. So as I said, this is the kind of approach that that Spork is using, or Zeus takes a little bit more of an aggressive approach, and can definitely make these times even smaller. So definitely check out the Zeus gem if you're not using it. And if this interested you, I definitely encourage you to check out my new online Unix programming workshop for Ruby developers. There's a link to it in the description here on the YouTube video or on the blog wherever you're looking at it. Check it out if you want to learn more stuff like this and see what kind of things like this are underlying your web servers, testing tools, your shells, and how it all fits together. Thanks.